Satellites are artificial objects placed into orbit around the Earth or other celestial bodies to perform various functions and tasks. They play a crucial role in modern technology, communication, navigation, weather monitoring, scientific research, and more. Here's a general overview of how satellites work. Launch. Satellites are launched into space using rockets. Once the rocket reaches the desired altitude, the satellite is deployed into orbit. The type of orbit depends on the satellite's purpose and mission requirements. Orbit. Satellites can orbit the Earth at various altitudes and speeds. Some satellites, like those used for communication, are placed in geostationary orbits, where they remain fixed relative to a specific location on Earth. Others, like those used for Earth observation or scientific research, may be in polar orbits, passing over different parts of the Earth on each orbit. Stabilization and control. Satellites need to be stable in space to perform their functions effectively. They use onboard thrusters, reaction wheels, or magnetic torquers to control their orientation and keep them pointed in the right direction. This stability is crucial for maintaining communication links, pointing sensors, or collecting accurate data. Power source. Satellites require a power source to operate their systems and instruments. Solar panels are the most common power source for satellites in Earth's orbit. They convert sunlight into electrical energy, which is stored in batteries for use when the satellite is in the Earth's shadow. Communication. Communication satellites act as relay stations in space. They receive signals from ground-based stations and retransmit them to other locations on Earth. This process enables long-distance communication, such as television broadcasts, internet connectivity, and phone calls. Sensors and instruments. Different satellites carry various sensors and instruments based on their intended purpose. Earth observation satellites have cameras and sensors to capture images and data about the Earth's surface, atmosphere, and climate. Scientific satellites may have specialized instruments to study space phenomena or celestial bodies. Data processing and transmission. The data collected by sensors on the satellite is processed and analyzed onboard or transmitted back to Earth. Satellites use radio frequency, RF, signals to send data to ground stations. Ground stations. Ground stations are equipped with antennas to communicate with satellites. They receive the signals transmitted by the satellite and can send commands to control and operate the satellite. Ground stations are strategically located around the world to maintain continuous communication with satellites. Mission control. The operation and monitoring of satellites are typically managed from mission control centers. These centers oversee the satellite's health, orbit, and payload operations to ensure optimal performance and safety. End of life. Satellites have a limited operational life due to factors such as fuel consumption, wear and tear, or changes in technology. Once a satellite reaches the end of its operational life, it may be deorbited in a controlled manner to burn up in the Earth's atmosphere or moved to a graveyard orbit to reduce space debris. Satellites have become an integral part of our modern society, enabling global connectivity, enhancing scientific understanding, and improving various aspects of our daily lives.